Yeah, because you don't need to miss it more, sure. Thank you. All right. So yesterday we finished talking about something, a formula for how to find at least the cosine of an angle that wasn't on the trig chart. Okay, so we did all sorts of crazy work, and we ended up with a formula: cosine. Somebody read it off to me. It's cosine alpha minus beta. Cosine alpha, cosine beta. Was it plus or minus? Plus sine alpha, sine beta. Okay. So that was really good. I think we found out like the cosine of 15 or something like that, right? Okay. Believe it or not, that one formula took us like 25 minutes, I think, right? We're going to do 5 more formulas, but we're not going to worry about doing all that other stuff. One formula is only going to take us maybe about 2 minutes to do. The question is, what if I needed something like, the cosine of 75 degrees, where that's cosine of 30 degrees plus 45 degrees. It's great that I've got a minus there, but what if I need a plus? Okay? And for that, we just do a little bit of trickery. So, think of it like this. Cosine of alpha plus beta is the same thing as saying cosine of alpha minus negative beta. Would you agree with that, Mission? Yeah, okay. So, I guess we continue it on over here. So let's follow our formula here, where we've got cosine negative beta. So we have cosine alpha, that's the same. Cosine negative beta, it's a little bit different, plus sine alpha sine negative beta. All right? Now look back on your notes from 2 days ago. We had cosine of a negative angle. What did that turn out to be? It was one of those, I think it was a reduction formula. It was like cosine of negative x equals cosine x. It's just the same thing because it's the same in the positive and negative territory. So actually, cosine of negative beta turns into just cosine beta plus sine alpha times, somebody else look in your notes, sine of negative of an angle. So like sine of negative x. What did that turn out to be? Was it just sine x over here, like cosine? All right, Shelby, what was it? It was negative sine of x, because if you remember, when sine's positive over here, the positive x values, you have to switch all of those. It's like you took this whole thing and reflected it there across the x-axis. So that was negative sine, and we could just put regular beta right there. And if that's the case, putting a negative right there, that's really kind of annoying. We'll just push that over here and write this as cosine alpha cosine beta minus sine alpha sine beta. So it's kind of an interesting phenomenon when I have cosine alpha plus beta, there's a minus right here. When I have cosine alpha minus beta, then in between here there's a plus. So one of the ways that we, as mathematicians, we really like both those formulas, but we don't want to write both of them down. So this is what we do. We say minus, there's a plus, and then for plus, there's a minus. There we go. We just wrote two formulas in one. Y'all see how that is? So it's not like plus or minus here equals plus or minus here. It's minus will make a plus, and positive term right there, plus, you're going to put minus. Okay? So that allows us now to figure out what the cosine of 75 is. It's no longer a mystery. That's cosine of 30 degrees plus 45 degrees. So we can fill that out here. That's going to be cosine 30 times cosine 45 plus or minus. Which one do you think? Minus. Matches right there. Minus. Sine 30 sine 45. Get out your tree chart and we'll plug these in. So cosine 30 degrees. Cosine 45. Root 2 over 2. Sine of 30. 1/2. Sine of 45. Root 2 over 2. So, if I multiply these, remember you can multiply radicals by just bringing everything under one roof. So, square root of 3, square root of 2 turns into square root of 6 over 4 minus 1 times root 2, so root 2 over 4, which, yep, turns into, we'll say, square root of 6 minus square root of 2, all over 4. And the nice thing is that is the exact answer. Now, is it rational? No, because it's not a ratio of two integers, but it is exact. And that was one of the things that we were going for. And you know, it's not as pretty as root 3 over 2, or root 2 over 2, or even 1/2, or the negative of all of those, but you know, it's really nice, and that allows us to find, you know, sines and cosines of 15, 75, all those other angles that are kind of in between that we hadn't dealt with. And now you may be thinking, well, what about tangent, right? Well, there is a formula for tangent, and this one you can just pull out your trig chart and notice that it's been there all along. Y'all see where we are? Bottom left of the trig chart. Well, I guess you might even be thinking, what about sine? Well, here's the sine formula. Sine of u plus or minus v equals sine u cosine v plus or minus cosine u sine v. So what they are using as u and v, we've just been calling alpha and beta. That's pretty much the same kind of thing. And then you can, right below that, you've got the cosine, and then you have the tangent formula, tangent of u plus or minus v. Now this is a little crazy here. Tangent u plus or minus tangent v all over 1 minus or plus, and that order is important because it has to match whatever you've got over there. Tangent u, tangent v. All right. Look at the wrong thing. All right, so that was the new formula. That's 1, 2, 3, 4, 5. So 5 new equations there, plus the one we learned yesterday brings it up to a total of 6.
So for tangent, if on the left side is a negative, then on the right both have to be positive, right? There's a numerator.
If you're using plus here, then you do plus here and minus here. We'll do a problem just like that here in a second. So on the notes here, Matthew, whenever you need to speak out, just go ahead.
Give us 30.
Okay.
Give one to Kim, please. On the notes, on one side, I've actually gone to the trouble of printing out all of those steps for the law of cosine, or the sum of cosines, which that's great. But let's go ahead and let's do one of these sine problems first. What do y'all like there, 21 through 26? Sine of, you want to do sine of 75? Or sine of 75. So, sort of a hidden first step on all of these is you need to think of what are two numbers that are on my unit circle that I can add together or subtract together in order to find that.
30 and 45.
Well, 30 and 45, yeah, because that's pretty much obvious on this one. So it might be helpful if you were to label that, that's the U and that's the V.
So will the lowest degree be the U? All of them?
Well, it does not matter because you could just switch it around. It's just the first one, you know, you just need to have them labeled and have some sort of an order there. Okay, so I'm gonna trust y'all here. Plug it into the formula, read off to me. You want to write the formula down? I guess we're gonna have to have it memorized for the memorization quiz, so might as well. Just tell them. Somebody call out to me, what's the formula here for sine of U plus V? Yeah, give me U's and V's
so
first.
Sine U times sine V plus, plus, and then cosine U, and then
Cosine U, cosine V?
Yeah.
That doesn't seem right.
What?
Sine U cosine V
Yeah.
plus cosine U sine V.
Okay, so that's sine.
That's the last one is sine. Cosine U, sine V,
Cosine U,
sine V.
sine V. Are we correct now? Okay, so it's sine, cosine, cosine, sine when it comes for sine. On the cosine, it's cosine, cosine, sine, sine. Okay, I think we can remember that. So now it's, since we write it up here, now it's really easy just to plug it in. So sine 30 degrees, cosine 45 degrees, plus cosine 30 degrees, sine 45 degrees. Alright, so let's get some new folks here. Shelby and Josie, thank you for your participation. We're going to get somebody else. Plug in some values for the unit circle. Sine 30? 1 over 2. Somebody else. Cosine 45.
Square 2 over 2.
Thank you, Jesus. Somebody else. Cosine 30?
Square 3 over 2.
This way. And sine 45?
Root 2 over 2.
Looks kind of familiar, but that's because we have a lot of the same values here. So we have root 2 over 4 plus root 6 over 4.
Is it
That looks,
plus?
Yeah,
Or is it minus? Cause
let's look at the sign. Are you telling me it's plus or are you telling me it's minus?
it's minus because in the 30 plus 45 would be minus.
No, yeah, it's for science.
Well, no, it's plus or minus.
No, it's plus.
Okay, okay, it is, let me see if I can explain to you here. It is not plus or minus. I know I said plus or minus earlier, that was a mistake on my part. Okay. I understand, okay. There are two formulas here. Here's the first one. Sine of U plus V equals sine U cosine V plus cosine u, sine of v. That's one formula. Here's the
Okay.
next one. Sine of u minus v equals sine u cosine v minus cosine u sine v.
So for sine, it's the same and it's not switched.
That is correct.
Okay.
And here we have root 2 plus root 6 all over 4. Okay. Let's pick another one of these with sine that's a little bit. What about the next one? Sine of 285. Anybody still need this? So, a little heart there for the sine.
Can it be any two, or is it?
It could be any two as long as they add up to 285.
Okay, so 270 and 15.
270 and 15? Okay. I like it, but I also foresee a problem.
The really big number to a really small number.
15's on there, never mind.
Yeah.
225 and 60?
225 and 60. Okay, yeah, that'll work. So, let's see, sine was, well actually I've got it right up there. So if you write the formula down every single time, then you won't be crying as much when you take the memorization quiz on these formulas. So I recommend just write it down every single time. So sine u, cosine v, remember that sine has the same sign, S-I-G-N. Okay, alright, it's Friday. Cosine u, sine v. So that's going to be sine 225 cosine 60 plus cosine 225 sine 60. Alright, call it out to me. What's the sine of 225?
Negative root 2 over 2.
Ooh, a negative. That's what I was hoping for. Cosine 60?
1/2.
Cosine 225?
Negative root 2 over 2.
Sine of 60?
Root 3 over 2.
Are we on agreement? Anybody have an issue? Okay. So this is going to be negative root 2 over 4 minus root 6 over 4. Wow, that's kind of interesting. All these seem to be having a little pattern there. So this is just going to be negative root 2 minus root 6 all over 4. All right. Let's do a tangent one, shall we? Tangent ones tend to get a little different. Anybody else have any questions about any of this stuff? All right. How about tangent 105? That's a different angle. So number 26 there. What are two angles that add together to equal 105? 60 and 45. So now we go back to the tangent formula. And once again, you write it down every time. You have that. So tangent u, am I going to put plus or a minus? Plus tangent v over 1, am I going to put a plus or a minus? Minus tangent u, tangent v. There's u, there's v.
Sorry. Wait, how do you know if you put a plus or a minus?
Good
I'm
question.
sorry.
No, I totally understand. The formula on your formula chart looks like this, right?
Yeah,
Okay. If you have the top one, choose top and top.
Okay.
If you've got the bottom one, choose bottom and bottom. Nope, that's not a problem. I always seem to not give good explanations on this. So tangent of u for 60 degrees is the y over the x. Okay? So root 3 over 2 over 1/2. Oh, man, we might need, okay. Plus tangent of 45. Root 2 over 2 over root 2 over 2. In the next step, we will reduce that to 1. Yep. Over. Now, if this isn't a complex fraction, I don't know what is. 1 minus tangent of u tangent. So those two things again. So root 3 over 2 divided by 1/2 times root 2 over 2 divided by root 2 over 2. But don't worry, everything will become beautiful here very quickly. So you have a fraction divided by a fraction, which we all know that fractions divided by fractions, you take the numerator times the reciprocal of the denominator. So this would be root 3 over 2 times 2 over 1. Okay, so that's going to cancel out here in a minute. Plus, if we notice this one, it's the same thing over itself, which tangent, that's always the case because the y and the x match. So, plus 1 all over 1 minus, this is going to be that same thing, root 3 over 2 times the reciprocal of the denominator, 2 over 1 times this value right here, which is 1. Let's keep it going. We have in the numerator square root of 3 plus 1, and in the denominator 1 minus, those two's cancel, and that's times 1, so just square root of 3. Is that what y'all have? That's great. But we're not done yet. Because we do not like square roots in the denominator. It's sort of standard practice to get rid of that thing. The way we get rid of that is by multiplying by the conjugate of the denominator. The conjugate is just the opposite sign, S-I-G-N, of that right there. So 1 plus square root of 3. 1 plus square root of 3. The reason is, in case you forgot, because this has an A minus B appearance, this has an A plus B appearance. And does anybody remember what A minus B times A plus B equals? It's not C.
A squared.
A squared minus B squared. Yeah. So our denominator is just going to be 1 squared, which is 1, minus the square root of 3 squared, which is 3. So negative 2. Yeah. Well, I'll do that in part in a second. Yes, but you're correct. And my numerator is square root of 3 plus 1 times 1 plus square root of 3. If you want to leave it like that and then FOIL it, you can. I might rewrite this as 1 plus the square root of 3 times 1 plus the square root of 3, because that has the appearance of A plus B times A plus B. And this is why it's helpful to know all these things just off the top of your head. What's A plus B times A plus B?
A squared plus 2AB plus B squared.
Yep. Hooray for Algebra 2, saving us time, because that's going to be 1 squared, which is 1, plus 2 times A times B, so 2 times 1 times the square root of 3, plus b squared. So square root of 3 squared is 3. All over trace negative 2. Are we done yet? We're close. 1 plus 3 is 4. 4 plus 2 square roots of 3 divided by negative 2. However, I can actually split this up into 4 over negative 2 plus 2 root 3 over negative 2. Or I could have factored out a 2. There's all sorts of different ways I can handle this. But my final answer here, I believe, we'll check. 4 over negative 2 is negative 2. 2 over negative 2 cancels out, and I just have a minus square root of 3. Oh my gosh, so much work. But that looks pretty good. That looks exact. Now, somebody who's got a mind for shortcuts. How can I check this? Don't take shortcuts. How can I check it? Gabrielle, how can I check to see if this is right? Tangent of 105 degrees. Okay. Put what in the calculator?
Tangent 105 and then negative 2 minus 2.
Yeah, and let's see if they're equal. Okay. Which one? This one or that one? This one over here is negative 3 point.
And the tangent of 105 is the same thing.
Negative 3.73, blah, 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 blah. Does it match all the way out?
Is yours an 8?
It's totally exact, and that's great. Now you say, oh, well, why don't we just type that into the calculator and we'd be finished?
It's not exact.
It's not exact. And you're like, well, who cares if it's exact? It's accurate to 8 decimal places. Okay? Well, the thing is that later on, and we'll see this, I mean, we saw this right over here. Sometimes you'll have things that are going to cancel out. See what I'm saying? And if you have root 3 and root 3, or we had that root 3 and we squared it and it turned out to be 3 and everything cancels to just, whole numbers right here, integers actually. So the thing is that we want exact because when we're plugging things in, sometimes things will cancel out. Otherwise, we can get weird round off errors. If we start doing this, then we're going to round off and then things are going to have a level of error. And then every time we utilize that to calculate something else, then that error just gets bigger. And if we use this for, multiple thousands of devices or, using this as a process over and over and over, millions or even billions of times, then that error can get very large very quickly. So if we have the opportunity to find an exact answer, I'm going to take that exact answer. For all intents and purposes, I'm satisfied that you know where the first formula came from and then definitely how to use these other 5. So what did we talk about? What are these formulas? Anybody know the title of them?
I did. No.
Sum and difference formulas.
These on a trig chart are called the sum and difference formulas because they deal their formulas with sums and differences. Okay, so all right, there you go. Now you know how to find the exact answer for those different angles.